In the arid deserts of southern Peru, nestled along the rugged coastline of the Paracas Peninsula, an ancient mystery lies buried in the sands of time. In 1928, Peruvian archaeologist Julio Tello made a startling discovery that would perplex scientists and spark the imaginations of researchers for decades to come. Hidden within the necropolis of Paracas, Tello unearthed a series of elongated skulls, distinct in their shape and size, unlike anything seen before. These skulls, now known as the Paracas skulls, exhibit cranial features that are markedly different from those of typical human skulls, raising questions about their origins and the people to whom they belonged. The Paracas skulls are among the most distinctive and enigmatic human remains ever discovered, characterized by several unique cranial features that set them apart from those of contemporary and other ancient human populations. These features have sparked intense debate and speculation, particularly because they differ so markedly from the standard human cranial morphology. The most immediately striking feature of the Paracas skulls is their pronounced elongation. While cranial elongation has been observed in other ancient cultures through the practice of artificial cranial deformation, binding the heads of infants to shape the skull as they grow, the Paracas skulls exhibit a degree of elongation that is both extreme and unlikely to have been achieved through this method. Several of the Paracas skulls have cranial volumes that are up to 25% larger and 60% heavier than those of typical modern human skulls. This suggests that the elongation could be a result of natural genetic factors within this population. The implications of such a natural elongation are profound, as it would indicate an evolutionary adaptation unique to the Paracas people, potentially linked to their cognitive or social development. The increased cranial volume observed in the Paracas skulls suggests a larger brain size compared to that of contemporary human populations. This feature could be indicative of enhanced cognitive abilities, possibly providing the Paracas people with advanced problem-solving skills, technological innovation, or complex social structures that might explain their influence on early human civilization. Larger brain size does not automatically equate to higher intelligence, but in the context of the Paracas people, it raises the possibility that they developed advanced knowledge in areas such as astronomy, engineering, and art, fields in which their potential influence is observed in the creation of the Nazca Lines and other megalithic structures. Beyond the obvious elongation, the Paracas skulls exhibit other structural differences that distinguish them from those of modern humans and other ancient populations. The Paracas skulls often have significantly larger eye orbits, suggesting that the Paracas people might have had larger eyes or different ocular capabilities. This feature could indicate adaptations to environmental conditions, such as low light levels, or could be linked to other unknown aspects of their physiology. Some Paracas skulls display variations in jaw shape and dental patterns that are not typical of other ancient human populations. These differences might reflect dietary adaptations, or could be related to genetic isolation, where the population developed unique traits over thousands of years. In human skulls, the sutures, joints between the bones of the skull, typically remain visible into adulthood. However, many Paracas skulls exhibit reduced or almost absent sutures, which is unusual and could suggest a different developmental process or a distinct genetic lineage that influenced the fusion of cranial bones differently than in Homo sapiens. The unique cranial features of the Paracas skulls challenge conventional views of human evolution. If these features are not the result of artificial deformation, but rather a natural adaptation, they suggest that the Paracas people may represent a distinct branch of the hominin family tree. This would imply a complex evolutionary history where different human populations evolved independently for extended periods before coming into contact with one another. The Paracas skulls may thus offer evidence of a divergent evolutionary path, one that resulted in significant physiological differences alongside potential cognitive advancements. This divergence could explain why the Paracas people developed distinct cultural practices, advanced technologies, and possibly even influenced early human civilizations in ways that have been preserved in myths and monumental structures. Over the years, various theories have emerged to explain the origins of the Paracas people and the nature of these mysterious skulls. Some even have suggested more speculative ideas involving extraterrestrial origins. However, we take a more terrestrially grounded approach. Geographical and genetic isolation likely played a significant role in the development of the Paracas people's unique cranial features. Isolated from other human populations, they would have experienced limited gene flow, allowing distinct traits to become pronounced and fixed within the population. This isolation could have led to the development of larger brains, elongated skulls, and other anatomical peculiarities that are rarely seen elsewhere. In the context of evolutionary biology, such isolation can drive the emergence of new species or subspecies, leading to significant morphological and genetic differentiation. The Paracas skulls may therefore represent the physical evidence of a population that evolved along a unique trajectory, only later coming into contact with other human groups. Adding to the intrigue, recent genetic testing has revealed that the Paracas skulls contain mitochondrial DNA, with mutations that are not found in any known human or hominin species, sparking further speculation about the identity of this enigmatic population. This discovery has led to a re-evaluation of human evolutionary history and the possibility that the Paracas people may represent a previously unknown branch of the human family tree. Despite extensive study, many questions remain unanswered. Who were these people? How did they develop such distinctive physical traits? And what does their existence tell us about the broader story of human evolution? The mystery of the Paracas skulls touches on broader questions about the complexity of human evolution, the interactions between different hominin species, and the rise and fall of ancient civilizations. As we delve deeper into this enigma, we explore a theory that seeks to unravel the secrets of the Paracas people, one that challenges conventional understanding and opens the door to new possibilities in the story of our ancient past. We propose that the Paracas skulls may represent a long-separated advanced offshoot of the Neanderthals. This theory, grounded in the principles of convergent evolution, genetic divergence, and the reintegration of ancient populations, offers a compelling narrative that challenges our understanding of humanity's past. To begin with, the Paracas skulls challenge our understanding of human evolution, hinting at a deeper and more complex history than traditionally believed. Our theory begins with the notion of patterns of long-term evolutionary divergence and convergence, where different branches of the human lineage split, coexisted, and reintegrated. This idea finds support in the genome of modern human populations, showing traces of DNA from Neanderthal, Denisovan, and other populations, demonstrating that they once lived together and interbred. The theory proposes that the Paracas skulls represent a population that diverged from the main human lineage, evolving in isolation over thousands of years. The Neanderthal connection offers a crucial clue. Neanderthals, who once inhabited Eurasia, are known to have interbred with early Homo sapiens. While often dismissed as primitive, ancient megalithic structures found on Malta demonstrate successive phases of construction to track star alignments that indicate a timeline of hundreds of thousands of years, suggesting that Neanderthals and not humans were the driving force behind their construction. These massive stone constructions hint at an advanced understanding of architecture and engineering. Neanderthals themselves possessed a large brain volume, and much of what could be known is lost to time. But what is more clear is that Neanderthals, who dominated Europe for more than 500,000 years, could have produced numerous offshoots that, once separated, could both interbreed with other hominid subspecies and evolve distinctly on their own. Considering the Paracas population as a unique offshoot of Neanderthals, evolving separately and developing distinct physical traits, such as a larger cranial capacity, suggesting advanced cognitive abilities, sets this group apart as an exceptional population with unique evolutionary developments. This Neanderthal-derived population likely remained isolated, evolving independently for tens of thousands of years. Over this extended period, they developed significantly larger skulls, which housed larger brains, possibly indicating advanced cognitive abilities. This evolutionary path suggests that they could have been responsible for early technological and cultural advancements, predating and perhaps influencing known human civilizations. The connection between the Nazca Lines and our theory regarding the advanced Paracas civilization is significant. If the Paracas people were a sophisticated offshoot of Neanderthals with enhanced cognitive abilities, their ability to conceive and execute such large-scale designs suggests an advanced understanding of geometry, spatial relationships, and perhaps even astronomy. The Nazca Lines, etched across the desert plains of southern Peru, are among the most extraordinary and mysterious ancient structures in the world. These enormous geoglyphs, depicting a range of animals, plants, and abstract shapes, are spread over nearly 1,000 square kilometers and are best appreciated from an aerial perspective. From the ground, the full scale and intricate design of these figures are difficult to discern. It is only from high above that the true scope of these creations comes into focus, raising compelling questions about their purpose and the capabilities of the civilization that created them. The Nazca Lines, with their stunning visibility from the sky, suggest a level of sophistication in their creators that challenges conventional views of ancient civilizations. The idea that the Paracas people, an advanced offshoot of Neanderthals, might have developed some form of flight or aerial observation offers a compelling explanation for how these geoglyphs were designed and constructed with such precision. Whether for astronomical purposes, navigational aid, or religious expression, the Nazca Lines stand as a testament to the ingenuity and advanced capabilities of a civilization whose achievements were meant to be appreciated from the skies. One of the most striking features of the Paracas skulls is their large cranial capacity, which suggests that the population responsible for these skulls might have had larger brains and possibly advanced cognitive abilities. However, this distinctive trait likely came with significant reproductive challenges, particularly for the Paracas females. In human development, a substantial proportion of prenatal growth is dedicated to the head, which makes childbirth a delicate process. The size of an infant's head relative to the mother's birth canal is a critical factor in childbirth. For the Paracas population, with their larger-than-average cranial size, this would have posed a serious risk during childbirth, potentially leading to high mortality rates among both mothers and infants. In humans, the size of an infant's head relative to the birth canal is a key factor in determining the safety of childbirth. For Paracas females, the larger-than-average skulls of their infants would have made natural childbirth extremely difficult and dangerous. The risk of obstructed labor, where the baby's head is too large to pass through the mother's pelvis, would have been high, leading to increased rates of maternal and infant mortality. These reproductive challenges would have posed a serious threat to the survival of the Paracas population. High maternal mortality would have not only reduced the number of women capable of bearing children, but also placed the entire population at risk of decline. Without a viable solution to this problem, the population's ability to sustain itself would have been severely compromised. The unique cranial traits of the Paracas people, while potentially linked to advanced cognitive abilities, would have come at a significant cost in terms of reproductive health. The dangers associated with childbirth, particularly for Paracas females, would have created a critical challenge for the population, necessitating adaptive strategies to ensure their survival. Facing potential extinction, this advanced population may have sought to resolve this crisis through a deliberate strategy of reintegration with other human populations. By selectively interbreeding with Homo sapiens females, they could have introduced smaller skull sizes into their offspring, alleviating the reproductive challenges while preserving their distinct lineage. This deliberate reintegration would have been a calculated effort to ensure the survival of their unique traits and civilization. The integration of their males into the Homo sapiens population had profound genetic implications that help explain the disappearance of the unique mitochondrial DNA originally carried by the Paracas population. To understand this, it's crucial to consider the role of mitochondrial DNA in human reproduction and how the specific reproductive strategies of the Paracas people might have led to its eventual loss. Mitochondrial DNA, mTNA, is inherited exclusively through the maternal line, passed from mothers to their offspring. In the scenario we propose, the Paracas population, with their distinct physical traits and larger cranial capacity, faced significant reproductive challenges. The large skull size of Paracas infants would have made childbirth extremely dangerous for Paracas females, likely leading to high mortality rates among both mothers and infants. To address this issue, the Paracas population might have adopted a reproductive strategy that involved selective interbreeding with Homo sapiens. However, to minimize the risk to their own females, it is plausible that Paracas males were the ones who primarily interbred with Homo sapiens females, rather than Paracas females bearing children themselves. This strategy would allow the Paracas population to pass on their genetic traits while avoiding the high risks associated with childbirth for Paracas women. Since mitochondrial DNA is passed only from mother to child, the offspring resulting from unions between Paracas males and Homo sapiens females would inherit the mtDNA of the Homo sapiens mothers, not the Paracas females. Over generations, as interbreeding continued and Paracas females became less involved in reproduction, the unique mitochondrial DNA that once characterized the Paracas population would have gradually disappeared from the gene pool. This would leave behind only the nuclear DNA from the Paracas males, leading to a genetic legacy that is partly preserved in modern populations, but without the distinct mtDNA that could have linked them directly to their Paracas ancestors. This explains why, in modern genetic studies, we find little to no trace of the original Paracas mitochondrial DNA. Instead, we find other genetic markers, potentially linked to Neanderthal or other ancient lineages that suggest an ancient mixed ancestry. The absence of Paracas mtDNA is therefore not a mystery, but a logical outcome of a deliberate and necessary strategy to ensure the survival of their lineage while mitigating the reproductive risks faced by their females. The disappearance of the unique mitochondrial DNA and the interbreeding strategy employed by the Paracas population may also offer a new perspective on ancient legends and mythologies that have persisted through the ages. Many of these stories, often interpreted as purely mythological, could be echoes of real historical events, specifically the interactions between the advanced Paracas population and other early human groups. One of the most intriguing references comes from the biblical book of Genesis, where it speaks of the sons of God, who took the daughters of men as wives. This passage has puzzled scholars for centuries, with various interpretations ranging from divine beings to ancient rulers. In light of our theory, however, this could be seen as a symbolic representation of the interbreeding between the Paracas males and Homo sapiens females. The sons of God could represent the advanced Paracas males, whose larger cranial capacity and advanced cognitive abilities set them apart, almost deifying them in the eyes of other human populations. The daughters of men, on the other hand, would represent the Homo sapiens females with whom they interbred. This union, driven by the need to ensure survival and reduce the reproductive risks faced by Paracas females, could have been remembered and mythologized as a significant and impactful event in human history. Similarly, the Anunnaki of Sumerian mythology, often depicted as gods or beings from the heavens, could also be reinterpreted through this lens. Rather than viewing the Anunnaki as literal deities or extraterrestrials, they might be understood as a historical memory of the Paracas people, who were technologically and intellectually advanced compared to other human populations of the time. The Anunnaki were believed to have descended to Earth and played a role in the development of human civilization, including the creation of monumental structures and the imparting of knowledge. This narrative aligns with the idea that the Paracas people, with their advanced capabilities, could have significantly influenced early human societies, contributing to the development of technologies, cultural practices, and even monumental architecture, such as the Nazca Lines or other ancient megalithic sites. These ancient legends, then, may not be mere flights of fancy or mythological inventions, but rather encoded memories of real events involving the interactions between different human populations. The advanced Paracas civilization, with its unique physical and intellectual traits, could have left a lasting impression on the early Homo sapiens they encountered, leading to stories that were passed down through generations and eventually became mythologized. As these interactions were retold and transformed into legend, the Paracas people might have been elevated to the status of gods or supernatural beings in the collective memory of these early societies. The stories of the sons of God, or the Anunnaki, therefore, could be seen as cultural remnants of a time when advanced human populations influenced the course of history, their legacy enduring not just in genes, but in the myths and legends that have shaped human consciousness for millennia. The theory we propose is firmly grounded in the processes of Earth-based evolution, offering a compelling alternative to more speculative ideas involving extraterrestrial influences. The Paracas skulls and the advanced capabilities of the population they represent can be fully explained within the context of natural evolutionary mechanisms. This approach suggests that human evolution was far more intricate and varied than traditional narratives suggest, involving multiple branches of hominins that occasionally diverged, evolved in isolation, and then reintegrated. The Paracas people, as an advanced offshoot of Neanderthals, represent a fascinating example of how different human populations might have evolved along separate paths while still sharing a common origin. Isolated from other groups for tens of thousands of years, the Paracas population likely underwent significant evolutionary changes, developing distinct physical traits, such as their larger cranial capacity, which might have conferred enhanced cognitive abilities. This divergence was not an anomaly, but rather a natural outcome of the complex and varied environments in which different hominin groups found themselves. As evidence accumulates, we increasingly recognize that human evolution did not follow a simple linear progression, but rather involved a web of interconnected paths. The Neanderthals, Denisovans, and other ancient human relatives, including potentially the Paracas people, contributed to the genetic and cultural diversity of modern humans. The Paracas population's advanced traits and achievements could thus be seen as the result of an extended period of isolated evolution, coupled with eventual reintegration through interbreeding with Homo sapiens. The Paracas civilization's advanced cognitive abilities could also provide insights into the construction of ancient megalithic structures, such as those found on Malta, the pyramids of Egypt, and other enigmatic sites worldwide. These structures, often attributed to later civilizations, might have roots that extend back to the influence or direct involvement of the Paracas people or other advanced groups that shared similar evolutionary advancements. These megalithic constructions are characterized by their scale, precision, and alignment with astronomical events, features that suggest a deep understanding of engineering, mathematics, and the natural world. The Paracas people, with their enhanced cognitive abilities, could have possessed the necessary knowledge and skills to initiate or significantly contribute to the development of such monumental architecture. Their influence might have persisted long after their distinct lineage faded, passed down through successive cultures that inherited and adapted their knowledge. The presence of advanced technologies, monumental structures, and sophisticated cultural practices in ancient civilizations is often attributed to external, non-human influences, such as extraterrestrials. However, our theory demonstrates that these developments can be fully explained by the natural evolution of human intelligence and culture on Earth. The Paracas people, through their isolated evolution and subsequent reintegration with other human populations, could have been the architects of these achievements. This Earth-based evolutionary hypothesis emphasizes the remarkable capabilities of ancient human populations. It suggests that the origins of advanced technologies and cultural practices are rooted in the natural progression of human evolution, rather than needing to invoke external interventions. The Paracas people, with their unique evolutionary path, provide a tangible link between ancient mysteries and the natural, earthbound processes that shaped human history. The legends and myths of ancient cultures, which sometimes describe beings of great knowledge or power, may indeed be reflections of encounters with advanced human populations like the Paracas. These stories, encoded in religious texts and oral traditions, likely contain grains of truth about the interactions between different human groups. The advanced capabilities of the Paracas people, whether in constructing megaliths or influencing cultural practices, could have been remembered and mythologized as the actions of gods or demigods, further embedding them into the cultural fabric of early civilizations. The Earth-based evolutionary hypothesis offers a cohesive and scientifically grounded explanation for the Paracas skulls, the advanced capabilities of the population they represent, and their potential influence on ancient civilizations. By focusing on the natural evolutionary processes that gave rise to the Paracas people, we can explain their advanced traits and achievements without resorting to extraterrestrial theories. This approach not only enriches our understanding of human evolution, but also provides a framework for interpreting the enduring mysteries of ancient history within the context of Earth's natural processes. The Paracas skulls represent one of the most intriguing mysteries in the study of ancient human populations. Through our exploration, we have proposed a theory that ties together the unique physical traits of the Paracas people, their potential influence on ancient civilizations, and the echoes of their existence in ancient legends. This theory, grounded in Earth-based evolutionary processes, suggests that the Paracas people were a highly advanced offshoot of Neanderthals, whose larger cranial capacity and cognitive abilities set them apart from other human groups. The challenges faced by this population, particularly the significant reproductive risks due to their distinctive cranial features, would have driven them to adopt unique strategies for survival. The high maternal mortality associated with childbirth in Paracas females would have necessitated adaptive responses, leading to the eventual disappearance of their unique mitochondrial DNA through selective interbreeding with Homo sapiens, a process that allowed their lineage to survive, albeit in a transformed state. We have also considered how the advanced capabilities of the Paracas people might have influenced the creation of monumental structures, such as the Nazca Lines. These geoglyphs, visible only from the sky, suggest a level of planning and precision that aligns with the idea of a population with advanced cognitive abilities. Furthermore, the myths and legends from various ancient cultures, including the sons of God in Genesis and the Anunnaki of Sumerian mythology, may be historical memories of interactions between early Homo sapiens and the Paracas people, encounters that were later mythologized as contacts with gods or divine beings, or more recently, extraterrestrials. Our theory calls for a broader re-examination of the conventional timelines and narratives of human evolution. It suggests that the history of human development is more complex and intertwined than traditionally believed, involving multiple branches of hominins that diverged, evolved, and occasionally reintegrated in ways that have left subtle yet profound imprints on both our genetic heritage and cultural memory. The Paracas skulls, with their unique physical and genetic characteristics, offer a tangible link to this broader story of human evolution. By reinterpreting these remains and the associated archaeological evidence within the context of advanced hominin evolution, we open the door to new possibilities in understanding the origins of human civilization. This theory is not just an intriguing hypothesis, it is a call to action for the scientific community to reassess existing evidence with fresh eyes. We encourage archaeologists, geneticists, and historians to re-examine the Paracas skulls, the Nazca Lines, and other related phenomena in light of this new perspective. Such a re-examination could lead to groundbreaking discoveries that challenge and enrich our understanding of humanity's complex and diverse origins. In conclusion, the Paracas skulls may represent more than just an ancient anomaly. They could be the key to unlocking a deeper understanding of the intricate web of human evolution, a history that is not only recorded in bones and artifacts, but also in the myths, legends, and monumental achievements that continue to inspire awe in the modern world.